In this video, I'm going to show you an example of how we lay out calculations involving moles and masses. It's quite important to lay these out correctly. Here's a sample question, and we'll work through it. What mass of sodium hydroxide, NaOH, would be required to produce 16 grams of the antacid milk of magnesia, magnesium hydroxide, MgOH2, by the following reaction? And they've given us a balanced equation. Now, often it's helpful to just work out what have we been given. What have we been given in the question? 16 grams of the antacid milk of magnesia, which is MgOH2. And what are we trying to find out? Mass of sodium hydroxide. And I often write that down. I'll often write mass of NaOH is question mark, and the mass of MgOH2 is 16 grams. You don't have to do that if it's clear in the question, but it can help you not to get confused later on. Now, how do we work this out? We've got the mass of sodium hydroxide. We need to find the mass of magnesium hydroxide, sodium hydroxide to magnesium hydroxide. Now, it can be tempting at this point. We've got the mass of magnesium hydroxide. A lot of students go straight to trying to find out the mass of the sodium hydroxide. They throw numbers into the equation with masses and go straight down from there to there. You cannot do that. So I'm going to rub that out. We cannot do that. Whenever you're given a mass and you're looking at an equation, you've always got to convert the mass to moles. Then, when we're in this part, this is when we can look at the equation. You can use the equation to work out if you've got this many moles of magnesium hydroxide, how many moles have you got of sodium hydroxide? Then once you know the moles of sodium hydroxide, you can work out the mass. So we always need to convert our masses to moles, and then we can convert back to masses at the end. Now let's get rid of that picture. So we don't want that there. Well, we've got rid of the drawing. Let's get rid of the whole thing. Okay, and let's get going with our question. So first thing we've got to do is convert this mass here, the mass that we know, this one here of magnesium hydroxide, into moles. So how do we do that? Well, the number of moles, and I put the name of the chemical in brackets. That's a common way to do it, and it avoids any confusion. The number of moles is mass over molar mass. In this case, the mass is 16 grams. What's the molar mass? Well, we need to work that out. So just to the side, we put the molar mass. You can put the chemical, but I think this is clear. So magnesium on the periodic table is 24.31, plus I've got 2 oxygens, plus I've got 2 hydrogens. And when I work all that out, I get 58.326. And so I can put that in over here, 58.326. I work it out, I get 0.2743, and I put moles. Whoops, 2.4743 moles. And you see how I've laid it out? Someone else could follow what I've done. Then, now that I've got the moles of magnesium hydroxide, I can use my equation. So from the equation, now what do I do with the equation? I want to know the ratio of moles of sodium hydroxide to moles of magnesium hydroxide. So what is that ratio? Well, the number of moles of magnesium hydroxide divided by the number of moles of NaOH, what is that ratio going to be? Well, I've got 1 mole of this for every 2 moles of that. 1 mole for every 2 moles of sodium hydroxide. That's the tricky step, getting that ratio. But I know that for every 1 mole of magnesium hydroxide, I've got 2 of sodium hydroxide, so that gives me the ratio. And I can then rearrange that, and it will give me the number of moles of NaOH is equal to 2 times the number of moles of MgOH2. Now that may seem easy, but sometimes the ratio is a bit more difficult and the numbers of moles are funny, so it is helpful to lay it all out. So what do I get? 2 times 0.2473. When I calculate that, I get 0.5486 moles. So I know now how many moles of sodium hydroxide I've got. Now that I know the moles of sodium hydroxide, I can convert that back to a mass. So what is my mass of sodium hydroxide? Well, it's exactly the same formula. Number of moles is mass over molar mass, although this time, let's have a look. Here's our molar mass triangle. We know that number of moles is mass over molar mass. But you can use this triangle if you're not sure about rearranging equations. Mass is equal to N times M. That's how you can use it. The top one is equal to the bottom two multiplied. This one is equal to this one over that one. So you can use that triangle to work out the formula, but in this case, mass is equal to number of moles times molar mass. So let's get rid of that. We know the mass is equal to number of moles times molar mass. The moles of sodium hydroxide, 0.5486. Whoops, 86. I got that from up here. Times, now I don't know the molar mass, so I have to work out molar mass of sodium hydroxide is equal to sodium, 22.99, plus oxygen, plus hydrogen. I add all those up, I get 39.998. So I need to multiply it by 39.998. And when I work that out, I get 21.9 grams. There's my answer. And normally, on a long question like this, I would write a clear answer. I would look back at the question, check I've understood it, what mass of sodium hydroxide would be required. And down here, I would write the mass of NaOH required is, and because up here in the question, we only had two significant figures, 16 grams, I would just ignore that. I would drop this to two significant figures. So I would say 22 grams. I've got units, I've got the right number of significant figures, and there's my answer. And it's okay that it's not perfectly neat. That's not a problem at all, as long as it's clearly laid out.